India's electricity grid is a sprawling, colossal machine. Right now, it's being pushed to its absolute limits to feed the energy appetite of the world's fastest-growing major economy. Look at this chart tracking the grid's output. To meet that surging power demand, facilities are working overtime, and for the 2024 to 2025 financial year, total carbon emissions from grid electricity climbed to 1,234.19 million tons. Industrialization on this scale requires an immediate, massive surge in power generation, a requirement that, for now, remains tied to the existing fossil fuel infrastructure. Yet, beneath that rising total volume, the statistical nature of the grid is changing. Even as total emissions hit record highs, the actual process of generating electricity is becoming cleaner. This line graph tracks emission intensity, the carbon released per unit of electricity. It has dropped to 0.710 tons of CO2 per megawatt hour. These lines move in opposite directions. While raw carbon tonnage climbs, the pollution produced for every new megawatt falls. Resolving this paradox, how a country can emit more carbon while cleaning its grid, is the key to understanding if rapid economic growth can survive a carbon-constrained world. This drop in intensity is being driven by physical infrastructure on a massive scale, with new renewable installations now stretching toward the horizon. Over the last decade, renewable generation has scaled from 53.06 billion units to over 255 billion units in the 2024-25 period. Injecting this volume of zero-carbon electricity into the national system works to dilute the carbon concentration of the entire grid, pulling the national average down. We track this trajectory using the build margin, focusing exclusively on the emissions of the newest power capacity added today. It sits at just 0.512 tons of CO2 per megawatt hour, meaning new additions are significantly less carbon-intensive than the older infrastructure. Large-scale wind projects like these turbines are a primary factor in keeping the emissions for new capacity so much lower than the historical baseline. Because the build margin is lower than the current grid average, the ongoing power system expansion is effectively decoupled from the high-carbon methods of the past. However, relying on renewables introduces a physical challenge. When wind dies down or cloud cover moves in, green power generation drops in seconds. To prevent blackouts, the grid requires dispatchable power, energy sources that can be dialed up instantly to maintain a constant, stable frequency. India uses legacy hydroelectric dams to solve this. By adjusting spillway flow, operators inject zero-carbon power to stabilize the grid whenever renewables fluctuate. This balancing act is managed by organizations like NHPC and the Bakra Biaz Management Board, which treat these dams as the grid's primary shock absorbers. Nuclear energy plays a parallel role. These must-run plants provide a steady, low-carbon output that doesn't change based on weather or time of day. Managed by the Nuclear Power Corporation of India, this nuclear capacity provides a constant floor of power that allows variable wind and solar to operate safely on top of the system. Without these reliable, dispatchable baseloads, the 255 billion units of renewable energy would likely fluctuate too wildly for the national grid to handle. As long as the economy continues to grow at this pace, the sheer volume of power required will likely keep total absolute emissions high in the immediate future. But the data shows that the grid is no longer growing in the same way it used to. The massive expansion of renewable volume is beginning to outpace the carbon intensity of the older system. This transition relies on a specific balance, using legacy hydro and nuclear assets to stabilize the grid, while new capacity is built with a much lower carbon footprint. The 2024-25 data provides a practical look at how a developing nation can scale its total energy output while simultaneously reducing the carbon cost of every unit produced. India's current path shows that the trajectory of economic expansion and the trajectory of carbon intensity are no longer locked together.